Okay, let's do problem number 2. Problem number 2 example for friction problems is actually a problem where it's going to be traveling the box, that is, at constant velocity. Anytime you see those words constant velocity, it actually will make the problem, for the most part, a little bit easier. So problem number 2 says the coefficient of sliding friction for wood on wood is 0.55. What is the force of friction, FF, of a wood block of mass 2.5 kilograms being pulled on a wood floor at constant velocity? Now, don't forget, we do have a recipe for doing these, and the recipe should be followed. And we went over this in the last video. There are 8 things that you got to keep track of, but probably the most important thing is that free body diagram with everything labeled correctly. That's forces, magnitudes, and arrows. Make sure you list all the givens, and again, usually once you make your diagram, the givens are usually part of the diagram. Other important information: if they give you mass, which they did in this problem, immediately calculate weight. If they give you weight, well then calculate mass. Now again, since these problems in the beginning of this chapter are all on level surfaces, then we can immediately write down that the normal force is equal to the weight. And this problem does apply for step 5 here. It is a constant velocity problem, and because it's constant velocity, then we can immediately set the frictional force equal to the applied force. Other formulas, again, that you're going to be given: FF equals mu Fn, FW equals mg, and the net force is equal to mass times acceleration, which is Newton's second law. And again, don't forget to use your PowerPoint as a guide to doing these problems. So let's go ahead and do this problem here. So step number 1, of course, is again to draw your free body diagram. And in this particular problem, they tell us the mass is 3.5 kilograms. And I always draw the mass inside the box, because it's the property of the box. It's really not a force. Once we know the mass, we can immediately draw and calculate the weight, because the weight is equal to mass times gravity. So this is equal to 3.5 times 9.8. So FW in this problem is going to be equal to 34.3 newtons. And remember, all these forces, the unit is newtons. Since it's on a level surface, we can immediately then draw our normal force, which will be equal to the weight. So the normal force is equal to 34.3 newtons also. Now the problem says that the box is traveling at constant velocity, therefore the acceleration is going to be equal to 0, which is really important. And then the other important thing is that the applied force, therefore, must be exactly equal to the frictional force if in fact it's not accelerating. If it was accelerating, then these forces wouldn't be balanced. So what other information do we have? We have the information that the mu value for this particular problem is equal to 0.55. We also know that the formula that incorporates mu is mu equals FF over Fn. So if we plug in our values, we've got 0.55 is equal to FF over Fn, which is 34.3. And we solve for FF by cross multiplying and dividing, and we're going to find out that FF is equal to 18.9 newtons. Now we can plug in that into our free body diagram, which I always like to do. FF is equal to 18.9 newtons, but because everything is equal and opposite and balanced, because the acceleration is 0, I can then also write down that the applied force is also equal to 18.9 newtons. Now what we're trying to figure out is what is the force of friction, or in other words, frictional force, and we just did that right over here. So we're essentially done with this problem. And again, often if the problem says that it's traveling at constant velocity, it makes the problem a little bit easier, I think. And again, constant velocity means acceleration is 0, all the forces are balanced. We can go almost immediately to our mu formula, and we're going to figure out the frictional force And that's how to do a problem with that has zero acceleration or constant velocity.